The absolute value function is written as f of x equals the absolute value of x. That is how we write the absolute value function. So let's go ahead and complete this table. I'm going to go ahead and plug in the first x value in my table. I'm going to plug in a -3. Let's evaluate this. What's the absolute value of -3? 3. So guys, go ahead and put a 3. Let's plug in the next x value. If I plug in a -2, what is the absolute value of -2? 2. Can you guys fill out the rest of this table? Yes. All right, go ahead and fill out the table. Once you fill out the table, I want you guys to plot the points on your graph. Okay, so this is what you guys should have. Okay, so your domain, you read the domain from the left side to the right side. So on the left, we have an arrow. This pattern can keep on going. Even though it's not on your table, you can plug in a -4. The absolute value of -4 is 4. So that's right here. You can plug in a -10. What's the absolute value of -10? 10. That's up here somewhere. Okay, so you can continue this pattern. It'll go on forever to the left and forever to the right. Okay, so that's why we say the domain is -infinity to infinity. This is interval form. How did we say we write it for set notation? Yep, all real numbers. So it's a capital R with a double bar. Okay, now let's talk about the range. How do we read the range? Yes, not up, down. You start on the bottom. The very bottom here is at 0. The top goes up forever. You have arrows on the top. So this is 0 to infinity. So the way we write this in set notation, you're going to do braces, y, such that, and let's figure this out. Do you guys see that this is the very bottom of the graph? Everything is above it. What symbol do you think of when you say above? Greater. Okay, so we're going to do the greater than or equal to symbol. The y values are all greater than or equal to 0. That's how we're going to write the set notation. Okay, so this was the parent function. What does that graph look like to y'all? A V. It looks like a V. Now, the turning point, when I say turning point, let's read this graph from left to right. It's going down, right? And then it turns right here and goes up. This point right here, where it changed direction, that is called your vertex. That's called the vertex. That is where it changes direction. At first, it was coming down, it changed right here, and it's going up. That is called your vertex. Okay, so guys, this right here is the parent function. This is the most basic absolute value function. We're going to change it a little bit and see how our graph changes with it. Okay, so let's look at a next example. Before we do that, let's look at some steps. Now, to find the x value of the vertex, we're going to set the expression from the inside of the absolute value bars equal to 0 and solve. Let's do step number 1. We're going to set the values that are inside the absolute value bars to 1. So inside of the absolute value bars is x minus 4. Set it equal to 0 and solve. What is x equal to? 4, because you add 4 to both sides. Okay, so for my vertex, I know the x value will be 4. that's the little tip of the V shape, it'll be at 4, okay? I don't know the Y value yet. Let's see. So what I'm gonna do, guys, put that 4 in the middle of your table right here. Now we're gonna number up and down. So I'm gonna go backwards, 4, 3, 2, 1, and forwards, 5, 6, 7. So step 1, find the X value of your vertex. Step 2, put it in the middle of your table. Okay? All right, now just plug in your points. We're gonna find out what our values are. So I'm gonna write down the function. This is the function they gave us. Let's plug in numbers from our table. The first number in our table is a 1. Everyone, let's plug in a 1. Let's do this together. What's 1 minus 4? And what's the absolute value of negative 3? 3. So in your table, with 1, you get a 3. Now let's plug in the next X value. What is the next value in our table? A 2. So let's plug in a 2 this time. Plug in a 2. What's 2 minus 4? And what's the absolute value of negative 2? Okay. So 2 and 2. Let's plug in a 3 this time. Plug in a 3. What do we get? Negative 1, but the absolute value of negative 1 is 1. So we get a 1. What happens when I plug in a 4? You just get 0. You plug in a 4, you get 0. Okay, I'm just going to show you real quick. What do you think I'm going to get when I plug in a 5? Okay, guys, it's just going to repeat. 5 minus 4 is 1. The absolute value of 1 is 1. Our table is going to repeat itself. It's going to become 2, 3. Okay, let's go ahead and plot the points. 1, 3 is right here. 2, 2 is right here. 3, 1. 4, 0. It's creating a V shape now. We're going on the other side of the vertex. 5, 1. 6, 2. 7, 3. Guys, I want you to circle the vertex. 4, 0 was your vertex. So the numbers on each side of your vertex, they're going to match. So it makes a V shape. Do you guys see what I'm talking about? Okay. All right, so let's talk about the domain and range. It goes forever to the left, forever to the right. So your domain is all real numbers. It will always be all real numbers for absolute values. Okay, your range, where's the very bottom? 0. And it goes up to infinity. Were any of you guys thinking 4?
Yes.
Okay, 4 would be up here. This is at 0. We're talking about the Y values, not the X values, okay? Uh-huh.
How do we get the X?
All right, let's try this one. Remember, guys, what is the very first step? Set the inside equal to 0. And what do I get? I get X equals 3. This is the X value of your vertex that will go in the middle of your table. We're going to count down and up from that vertex. This one's your vertex. Okay, now let's just plug in numbers. Okay, so I'm going to erase this X. What's the first number in my table? 0. What's 0 minus 3? Negative 3. Okay, so I'm going to copy this down. Negative 2. I get a negative 3 plus 4. What is the absolute value of negative 3? It's just 3. Okay, I'm gonna put this in parentheses now. What's negative 2 times 3?
-6.
Negative 6. Plus 4 is negative 2. So when we plugged in a 0, we got out negative 2. Let's try the next x value. I'll just do a few of these. Okay,
Excuse me.
let's plug in a 1. What's 1 minus 3? But what is the absolute value of negative 2? Good. Bring everything else down. Now multiply these. You get negative 4 plus 4 is 0. So we get a 0 here. Okay, let's just skip around. I'll do the vertex next. Let's do the vertex. So I'm going to plug in a 3 this time to figure out where my vertex is. So plug in a 3. 3 minus 3 is? What's 0 times anything? So I just get 4. Okay, that's my vertex. So 3, 4 is my vertex. I have the points 1, 0. That's right here. I have the point 0, negative 2. It's going to create a V shape. So I know it's going to look like this. It's going to look like that. Okay, keep plugging in numbers. You'll get those points. Let's talk about the domain. Is it still left to right with arrows? Okay, so this is still negative infinity to infinity, but my range is a little bit different. Where's the bottom? Yep, the bottom has arrows. It's going down, so this is negative infinity. And where's the very top? 4. So that is your range. If you wrote this in set notation, everything is below 4. Okay? If you did set notation for this one, it would be all real numbers for the domain. Yes.
How do you graph like all this points? 3 points on the.
You just filled it in, but you can plug them in and get these points. I just didn't want to take all the time. But yeah, you can plug in each of these, plug in a 2, plug in a 4, 5, and a 6. You'll get these points that you see. Okay?